Good morning and welcome to the abbreviated version of Unit 8, Lesson 1, and actually Unit 8, Lesson 2. What I want you to do is you're going to take the Unit 8, Lesson 3, and it's going to go from graph paper to graph paper, okay, like so, okay, graph paper to graph paper, and I want you to use both sides to take notes over Lesson 1 and Lesson 2. So when you turn in Lesson 3, after doing all of the highlights and filling in everything for Lesson 3 by following along with the screencasts, you've actually turned in all of your notes for Lesson 1 and 2 as well. And the reason why I'm doing this, number one, is to save time. Number two is, the topic is not terribly interesting, so I don't want to spend just tons and tons of time on it. But there are some things from Lesson 1 and Lesson 2 that you do need to know. Lesson 3 sort of expands on those concepts, so you do need to have some familiarity with them before you listen to and understand Lesson 3. All right, so get your pens, highlighters, and whatnot ready, because this is what I want you to write down. So for Unit 8, Lesson 1, the sun provides the energy that drives convection currents that produce winds. The Earth's surface is not heated evenly, so some areas receive more direct sunlight than other areas. We learned about that when we did the seasons. Some areas receive sunlight for more hours than other areas. Again, we know that because we studied that when we learned about the seasons. And, this is really important, land and water heat differently, okay? Land tends to heat up fairly quickly, but it also tends to release that heat at the end of the day fairly quickly. So basically, land heats up quickly, but also cools down quickly. Water heats up and cools down more slowly. So water temperature is more reluctant to fluctuate, meaning that your water temperature is harder to change, but your land temperatures are a little bit easier to change. Anyway, okay, next point. Air moves from high pressure to low pressure, and this creates wind. Greater differences between high and low pressures mean stronger winds. Because the Earth rotates, winds do not move in straight lines, but they appear to curve, and that's just simply because of the rotation of the Earth. But this apparent curvature of the winds has a special name, and it's called the Coriolis effect. Okay? All right, I'm going to move up just a tad, and let's talk briefly about global winds. Global winds are large-scale winds that occur globally. Okay? There are three basic types of global winds that act at the surface of the Earth, and they are trade winds, westerlies, and polar easterlies. Trade winds sort of kind of go from east to west, so they're an east wind, meaning a wind is named by the direction it flows from. So if it's going from east to west, then it's an eastern wind. Anyway, trade winds are winds that you'll experience at the surface in general from the equator to about 30 degrees north and from the equator to about 30 degrees south. Then from 30 to 60 degrees, both in the northern hemisphere and the southern hemisphere, we have westerlies, which generally flow from west to east. Then towards the poles, we have the polar easterlies, again flowing from the east towards the west. Okay, the westerlies should be easy to remember because they're coming from the west in general. Polar easterlies should be fairly easy to remember because the name says easterlies, so it's flowing from the east. And the trade winds are also coming from the east, but it's not in the name. Okay, so those are your surface winds that act on a global scale. We also have some really important upper level winds. You may have heard the weather forecaster mention something called the jet stream. Those are upper level winds, and jet streams are important because they tend to steer weather. And there are two jet streams. There is the polar jet stream and the subtropical jet stream. And we won't talk a great deal about those, but just do know that those are upper level winds, meaning that they occur high in the atmosphere. They do not occur at the surface of the Earth. Okay? All right, next we have our local winds. Local winds are small-scale winds that blow from any direction depending on local features. So it's going to be different depending on where you are. We have sea and land breezes, and we have mountain and valley breezes. Winds are named by the direction they blow from, as you've seen when we talked about the westerlies and the polar easterlies. Wind is created as air moves from higher pressure to lower pressure. Okay, so lesson 1 is all about winds. So you need to understand the basic concept of winds. The sun is providing the energy, but it's not heating the earth evenly. So some places are being heated more than others. And so remember that when you have warm air, it expands and rises, and it's generally lower pressure. Cooler air has higher pressure. And so you get winds because basically the Earth is trying to redistribute the heat energy, and winds are one way to do that. Okay, so those are the basic points about Lesson 1, and I'm going to go on to Lesson 2 in just a second. So feel free to pause and either go back or whatnot so that you can write all of the notes down for Lesson 1. Okay, and once again, that should be written on one of the graphing pages that goes with Lesson 3. Okay, on the other piece of graphing paper, you should write your notes for Unit 8, Lesson 2. Okay, Unit 8, Lesson 2 is all about ocean currents. And ocean currents are stream-like movements of water in the ocean. And there are 2 types of ocean currents. There are surface currents and deep currents. Okay, surface currents are basically at the ocean's surface down to about 100 meters or so. Surface currents are largely caused by wind. The Gulf Stream is an example of a surface current. The Gulf Stream brings warm water up along the east coast of the United States. There's also the California current on the west coast, and that actually moves cooler water south along the west coast. So you kind of have an opposite effect. But anyway, the Gulf Stream and the California current are both important currents for you to understand. And, the Gulf Stream is on the east coast. The California current, obviously, is on the west coast. The Gulf Stream is a warm current, basically, bringing warm air from closer to the equator. And the California current is bringing cooler water from kind of the northern Pacific down along the California coast and Oregon and whatnot. Anyway, okay. Factors that affect surface currents. Continental deflections. Obviously, you can't have ocean water going where there's land, so it has to go around the continents. The Coriolis effect affects ocean currents. Remember, that is we're trying to go in a straight line from A to B, but because the Earth is rotating, it winds up looking like a curve. And then global winds are also affecting surface current. Because remember, up here, we did say that surface currents are caused primarily by wind. Okay, and ultimately all of this, sorry about that. Ultimately all of this is powered by the sun. Okay. All right. Over on the other hand, we have deep currents. These are far below the surface of the ocean, and they are caused primarily by differences in density. Okay, well, what affects the density of ocean water? And 2 things primarily affect the density of ocean water. Salinity, meaning how much salt is in the water, okay, because saltier ocean water is heavier, more dense. And then also temperature affects the density, because in general, warmer water is less dense and cooler water is more dense, okay? So those 2 things are going to be the big factors that affect the density of ocean water. Okay. All right. Down at the bottom, ocean currents transport two things primarily. Okay. Ocean currents move energy from place to place, primarily heat energy. And ocean currents also move matter, sediments and things like that. Okay, so ocean currents transport matter and energy. Okay, all right. It also says, now you do not have to sit and define these, but it does say to please know these terms, and you do need to know them. Ocean current, surface current, deep current, Coriolis effect, convection current. Remember convection currents we have talked about multiple times. We talked about them when we talked about plate tectonics, because magma, even though all magma, molten rock in the earth is going to be hot, some is hotter than other parts, and the warmer or hotter is going to be a little bit less dense and rise. The stuff that's not quite as hot is going to be a little bit more dense and sinks. And convection currents work the same way in the air, in the atmosphere, and in water, so in the oceans. Okay, you're going to have warmer fluid, whether it's air or water. You're going to have it rising, and you're going to have fluid that's a little bit more dense and cooler sinking. Okay? You also need to understand density. Remember, that's just how much matter is crammed into a certain volume. Salinity is basically the saltiness of water. And then upwelling is a concept that basically brings waters from the deep up towards the surface. Anyhow, those are the highlights of Lesson 2, and you should be writing those down again on a sheet of graph paper that's attached to Lesson 3.